Okay, so let's get started. The first two questions are just for each of us to answer individually. And then up here, this is the next one, 3. Um, we should note this, give all your probability answers as decimals. Do not give them as percents.
Okay.
So it says, use the following information to answer the next 3 problems. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the table below. Question 3. The blood types and the proportions given in the table above define a probability distribution. So I think that's yes,
Yeah,
because they all, when you add all these up together, they equal 1.
right.
Oh, okay. That's true.
Okay. And then who's up?
Oh, I'll take it. What is the probability that a randomly selected person in the United States has type O blood? Round to the decimal.
Oh, I'm sorry.
So it's okay. It's
Down to 2 decimals.
2. Oh, okay. So it's just like it says there. It's 0.45.
Yeah.
0.
And then I think we're supposed to put 0.45.
Oh yeah, yeah. That will be the correct way then. Yeah.
0.45. Let's save that. Okay. Number 5. Nydia?
What is the probability? Okay. What is the probability that a randomly selected person will not have type O blood? Okay. Can we see? Okay. It is 0.55.
Yep, I agree. Because it's just 1 minus 0.45, right?
Okay.
Yeah.
Thank you.
Okay. How many questions are there, anyways? 13. Okay, so 6. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tango, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability they correctly identified the dish containing the specimen from the bladder cancer patient?
Do we have to use that formula, the PX?
Not sure.
So it says one dog. Well, there were seven specimens, and one dog. What, Tango?
One.
Because the other 6 were just samples who did not have bladder cancer. So 1 out of 7.
I'm going back and reading. See if I can't find something. I don't know. I mean,
I really thought that we needed to use that formula. What is it? What is it? Parentheses X.
Yeah.
trying to pull it up here. So each time, how does this read? Well, that's. Isn't that just 1 in 7 chance?
Yeah, because
1 in 6?
there were 7 studies, and the dog Tango demonstrated it. The right one.
And so he's going to pick one, and only one out of them has the. So it should just be 1 divided by 7, right?
Yes.
And what does it say? 3 decimal places, so 0.143.
143. Yep.
I think that's right.
Should we put the 0 there though? Or
yeah, I think so.
All right. That sounds right.
Okay.
Because it was 1 out of 7.
I think so. I think I was just trying to overthink it, and when I really thought about it, it's pretty simple.
Okay. I know it's when you read it, it's like, oh, it's overwhelming, and then all of a sudden,
yes.
Yeah.
I gotta read it like
I agree.
3 times before it makes sense.
Okay.
Okay. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times.
Sorry.
It's okay.
Put that over that. There you go.
Thanks.
Okay.
It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that a dog can detect bladder. This is little evidence can detect bladder. I think is the first one. This provides strong evidence.
I agree.
Okay. Agree. No. Okay. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. Okay, there's the table. Question 8. If you reach into a bag of plain M&Ms, what is the probability of drawing a red color candy? Okay. Oh, we don't have the green, right? We need
No, but you
green
have the
before.
I just assume that
So,
one will get us to 1.
okay, let me check. What about if we add 0.13 plus 13 plus 13 plus 24 plus 0.20? Okay, minus 1. Oh, 0.16. Oh, but
Yeah, but
is
it's
that
just
okay?
asking for the red.
Yeah, it's just the red. And
Oh,
you have the red right there.
oh, you're right. Oh, okay. we got the now the green seal. Let me see. So, okay, let me check. 1 minus 0.13. 87?
It'd be 87 that you don't get a red,
Check.
but they're asking for the probability of getting a red one.
Getting, yeah, just getting the red.
Oh,
So
just the red.
Yeah.
0.13.
Yeah.
Okay, thank you. Thank you.
So what is the probability the random selected candy is green? And the green was the one that we didn't have, right? And so we added all these up, and what was left was 16.
Yes, I agree.
Yes, so what is the probability that a randomly selected candy is not green? So, what is it, 0.13? No.
Well, we know what green is.
Yeah, so we have to add all of them.
Or you can just subtract
oh, yes.
that from 1, right?
Yeah, so
yes.
That would be 0.84.
Yes. Okay. Okay. The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from CAPEX. The following summary statistics were calculated. Okay. Half of the observations are less than or equal to what number? Half of the observation are less than or equal to what number? Okay.
So remember, this was the quartiles.
Okay, we are talking about the median.
Yes, you are. Yep.
Okay, so it's 45.
Where'd you get 45?
No, 24. 24. Sorry.
You said the right thing and then the wrong number.
I don't know. I'm sorry.
Based on the information on the table above, the top 25% of the students scored above what number? So that's this third quartile, so above 27.
27.
Okay.
Which of the following statement is not one of the 3 rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will occur. probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. It's that one right there.
Okay. Should we submit this and see if we got it right?
Sure.
Okay.
Yay. Awesome.
Okay.
Yes. Thank you.
I don't know that I have time to do the whole lesson 5. Should we meet
That's
Thursday?
fine.
Is that okay?
Yeah, that's fine. We
Okay.
can meet Thursday. Is that okay?
Yes.
Okay, great. Let me pause this
Great,
thing.
Ben.
All right, I'll submit it again.
Okay, great. Thank you.
All right, talk to you
Thank
Thursday.
you very much. You too. Bye-bye.
Bye.
Bye.
Bye-bye.